Getting started with test-driven development can be quite daunting, and I hope in this video that I can show you that it's just an evolution of standard programming practices that you're already using, so making it easier for you to transition into having written specifications that prove that your code is working, making it easier for everyone to work together in the same code base. Hi, my name is Morten Nielsen. I'm a serial startup CTO. I focus primarily on building software products and getting teams to work effectively together and growing teams as we build the product. For this video, we're going to go through a very basic programming example, focusing on TDD practices and how just normal everyday operations and normal programming practices evolve eventually into test-driven development. We're going to do a little bit of role-playing where there's a product owner called Lisa that will come in and she'll give us new requirements for our functionality over time as we're working. The initial task that we got is to create a function called add numbers. It's very simple, it takes two numbers and adds them together. So it could look something like this. To see that this function is working, we can add a log statement that prints out the output to see that it's correct. And if we run this, we can see that it prints out 3, our code is working, we solved the initial problem. We can add another console log statement here to make sure that we have different scenarios to test to make sure that we actually see the output. Okay, so log statements are quite convenient. You can just add them in everywhere and you will have output that you can monitor and look at that log outputs and you'll see that your code is behaving correctly. It's a great tool for debugging or just monitoring your software as it's running. However, as your software evolves and grows, the output of your log statements become longer, bigger, and it takes more and more time to go through the logs and figure out what's going on. Wouldn't it be more convenient if we had a function that shows us that, oh, the software is broken in this place? For this, we can use something called assertions. Assertions is a simple function that verifies statements that you have about your software or ideas about your software, and then if they don't hold, your software will tell you that it's broken. Instead of you having to scan through a bunch of logs, your software will now instead tell you what's wrong. So it could look something like this. We create a new function called assert equals, takes AB, and if A does not equal B, throw a new exception. We can now use our new assert function to, instead of doing console logs, we simply do the asserts. And if something all of a sudden stops working, then our asserts will stop the program and terminate execution. So let's see what that looks like. We do this, assert equals. Now if we run our software, there's no output, but if we change, for example, this, then we can see we get an exception thrown telling us exactly where something is wrong and even a description of why it broke and what we expect it to do. A lot of programming languages have assertions built in. You can sort of have the compiler remove assertions if you don't want them running during production. But it's a great way to have certain checks in place to make sure that your code is actually working as you're developing it. Now, it can seem quite harsh to have a software crash because your expectations are wrong. But what we're trying to prevent here is data mutations that are made with mistaken data. And we're also preventing our program from going even more haywire if it starts returning results that we haven't designed it for returning. So having assertions in place is a sort of a way to make sure that your program will rather stop executing than create problems for the user's data, because the data is probably not always recoverable. So hopefully you can see that if we use this instead of log statements, we don't have to monitor the output logs as much because the software will tell us if something is not working. Okay, remember Lisa from earlier? Well, she now wants us to add more functionality to our little function here. She wants a function that can add 3 numbers and also add the 2 numbers that we already have. And just like we have specifications for how our software is going to work on a high level, why not have a specification where the coding example showing how this should work? It makes perfect sense when we're on a function level to have an example of this function, when executed with these inputs, should give this output. So why not have that as an executable check with an assertion? So for Lisa's new feature that we're going to implement, we're going to start by making sure that we understand the problem by writing down a specification complete with code examples. So let's see what that looks like. Insert equals. We will add numbers, but we want to add 3 numbers. And we expect this to be 9. Some of you will have noticed that this doesn't work. If we run this, we'll have a crash again because we are not handling the 3rd argument to our function. So let's add that. This is with the smallest code change we can think of. Let's see. There, this should work, right? But if we run this, we can see that the previous use case that we had is now crashing. And it's crashing because we're not handling undefined values. So to make sure that we have our previous use case working, we can add a simple little check to ensure that we're not crashing when we have an undefined values as the 3rd argument. And let's see what that looks like when we run it. And now we have no output, meaning that our program is running as we expect. As you can tell, because we kept our assertions that we had for the first use cases, adding a new one showed us that once we fixed the functionality for the new use case, we accidentally broke the old one. And this is the benefit of having executable code examples with the output stored for all the different use cases for your functionality. If you have them written down in an executable form, they will show you if you break prior functionality or functionality another part of the system is reliant on. Okay, so we added a new feature, we added a little bit of functionality. It's not clear from the code because it's not consistent. There's something not really right about the code. You can't read it and really understand the intent of what you wanted to achieve. So let's add some comments here to make sure that we have things working accordingly. Now we have a description of what happens with the 3rd argument when it's not there. We also have these random asserts in the code, so they're not really explaining what's going on, but let's change that. Let's add a little bit of more of a description to them so that we know what the assertions actually are going to check. So this is really helpful, especially for Lisa. She can come in and she can read these comments. So let's try and see if we can make something that works for Lisa as well. So we will describe our add numbers function, and we will say that it can add 2 numbers. And for the new use case, we will say it can add 3 numbers. Great. Now we have written down the behavior that we want for the function, both in code and what our Lisa, our product manager, expects our code to actually do. This way, we can change the code, but we can still maintain the specification of what Lisa wants the code to do, because we have a translation from human language into code language with a running code example of what the system should do. What we just did is a fundamental step in test-driven development. We started with writing down a specification of what we want the code to look like, and then we implemented that behavior. Because we had checks in place from our previous features, we made sure that we did not break anything. We maintained the quality from a user perspective, and while we added this new feature. We call having failing tests red and passing tests green. However, as a function becomes more complex over time, it becomes more and more unreadable. And as a function becomes more unreadable, it becomes harder to maintain. And over time, because complexity pushes forward in mostly all software development projects, we need to maintain the complexity of our functions. So we want to change our function, making it more maintainable, making it readable, making it easier for developers to understand, or maybe we need to speed it up. Having these green tests means that we can change our code. We can do what's called a refactoring of our code and to make tiny changes incrementally and still maintain a working software. There's a book called Refactoring by Martin Fowler that I don't have here. It's in the living room. I highly recommend reading it. It will show you how to step by step take small steps to improve your code quality, and hopefully the longevity of every software product that you work with from that point forward in time. All right, but now Lisa wants another change. She wants our function to accept undefined regardless of the position of the number. So in principle, it just means if we provide undefined in any of our variables, she wanted to be treated as 0. So let's see what a full red-green refactor cycle would look like implementing Lisa's new feature. So let's start out by making sure we have a red test. Now, I will describe it a little bit. It will treat undefined values as 0. We do this, and we can add another assert. Now, if we run this, we can see we get not a number because we aren't handling the second argument as undefined. So let's make the smallest possible change to our code so that we come into the green phase. Then we know that we have some sort of working software, but it might not have pretty code yet. So let's see, make that slight code change. And now when we run our code with the checks, we can see that it actually works. All right, we're now in the green phase. But looking at this code will, as we add more and more checks, it will just become more and more bloated with or statements, parentheses, and stuff. And also, if we would add more arguments to it, it will just become less and less readable over time. So I'm going to change this code now, and I'm going to introduce some JavaScript features, but don't be intimidated by them. I will explain what they're doing, and some of these are available in JavaScript and maybe not other languages. But if you worked with software development for a while, you will be familiar with what we're doing. So let's go into the refactoring and make our code prettier. I'd like to point out, as I'm moving the cursor around, that there are multiple ways of adding numbers. So I want to accept our input as an array of numbers. So this 3 dot here will make an array of the arguments, and now we have an array ready for us. So instead of going through each and every item, I introduce a MapReduce. So the MapReduce, I can make these more. The MapReduce is, it takes a function as the first argument. The function takes a current value and a number. I prefer this. And then it will run this function, and it will add the number to the current value for each element in the array. And it will start at 0. So it will start with 0, and it will take the first number of the array, add it, then the second number of the array, add it, and so on. And what we can see now, if we run our code again, our code is now functioning, but we now changed our code so that we can take an arbitrary number of arguments and we can have undefined in any place in the add numbers function. The refactoring phase of the red-green refactor cycle is now done. We clearly saw that by adding a red test and then making a small change, we had a lot of different All right, so I've done all this without using a testing framework. Now, a testing framework is just a collection of smart functions that helps you write these specifications, combining what the product owner or like what user of your code would expect as a code example with an actual executable code example. So let's just make some slight alterations to our code using the Jest testing framework, and then hopefully you can see that we were actually really, really close. So what I want to do now is I want to use a describe, the add number, and I've always been taught to have a double describe, because then I can use these different internal describes to group sort of behavior in our function. So in this case, when adding numbers, I could have another description here that is for adding floats or whatever, and then I can have the test setup match these setups and making it easier for me to create more test cases. Now, these are the describes. They're sort of like a context. Let's add the actual checks. So using normal human language, I like that. It can add two numbers. I add my assert equals. I complete the it function. There we go. That's our first test. I can now I can make sure that these are gone. I will now add another one. It can add three numbers. I can take my assert from down here, move it up here, and I have the last one. It will treat undefined values as 0. It will, there we go. And I can remove my test case here. Now, Jest has a built-in equality check. So let's use the expectations in a testing framework instead. So instead of doing assert equals, we do expect. And I can now change this. There we go. I can now get rid of my homemade assert function because I'm using the built-in one in the Jest framework. And there you go. Basically, what we're doing is we're combining asserts to reduce the need for log statements with documentation and specifications that are executable. And we're using these to guide our development process, making sure that we have a piece of software that we can confidently rely on as we're building more complex software on top of this function. So not only does this combine our documentation with executable code, we can also now move our test cases into a different file that it will reach production, because we don't need to have asserts in production code if we can rely on our software. There might still be cases where you want asserts in your production code in combination with tests, but you can have these as a part of your development environment and to make sure that the code is behaving the way you want it to behave. Okay, hopefully this video gave you a framework to sort of wrap your already existing software practices into test-driven development. And you can hopefully see that it's not really that hard. You might need to learn some of the Jest functions, but they're all available to you. They're well documented. You have a lot of examples. Just don't think of this as something different than actually just creating software in a team, showing your team members that the code works. Because test-driven development is not just about tests. It's also about collaboration and quality. So we're trying to create a shared understanding in our team of what our code should look like and how it behaves. So this improves collaboration and it reduces the amount of bugs over time. Start small and then gradually evolve and start adding more and more tests. And I promise that your code base will be better because of it. If you like this video, please like and subscribe, share it if you like. there's a link to a newsletter in the description below. Please follow the link and join my newsletter. You will get updates about blog posts and new videos. And if you sponsor, there's extra content in there every now and then with some extra blog posts that is available only for people who sponsor me. And sponsoring me is just buying me a coffee every now and then. So hopefully it's not meant to be expensive. But if you like, the option is there for you. Until next time, thank you. I'm Morten.